So, yeah, passive house, I'm going to talk about. As I say, I'm no expert, but Anne and myself embarked on a little project about a year and a half ago, which might end up with us building and living in a passive house. So we've kind of been learning a lot along the way. So sharing it from a non-expert point of view, and I'm sure there are some of you here who know more details. So as I usually do, I'm leaning on a lot of other people's bits of information. So passive house, sometimes spelt in the German way, as in the middle there, because that's where it began. But you also see it written as passive house in English. And I'll also say something about Enerfit, which you'll see the symbol for there, which is the equivalent of passive house for old houses being upgraded and renovated. So let's see. Why am I knowing a little bit about this? Well, this is where we live at the moment, that house there, which is a lovely family home. We've lived in it for 35 years. It's got a lovely garden. It's got fantastic views. You can see down at the bottom there, that's the view from our front window. It's got everything going for it, except for two things. One is that it's not going to be what they call a forever home these days, because it's full of stairs, and the bathrooms are upstairs and the bedrooms are upstairs and the stairs in the garden. And it's hard to heat because it's an 1880s stone-built house. So we started thinking about maybe we should be doing something different. But before we get there, we thought we'd, over the years, do all the kind of things that Kasia would probably advise you to do if you called around for a visit to your house to give you some advice. So we did all the things like draft-proofing doors, although that wasn't very successful with the kind of cheap plastic draft-proofing, which tended to come off after a little while. But we did our best, and we've got a big sausage draft excluder at the door we don't usually use. We insulated the loft. When we came to this house, that's not me, by the way. That's just a stolen photograph, but there was no insulation in the loft whatsoever. So we put in what was standard at that time, which is 3 inches. And then that didn't seem to make much difference. And then what, about 10, 15 years ago, I don't know how long ago now, when there were some grants available and they were recommending you went up to 12 inches, we did that and insulated that as much as we could. We put on a new back door because the old door was pretty thin. I don't think the new one's that much better. This house belonged to a double glazing salesman before we had it, and it was full of, every window was different. I think they were the ones he had left in his warehouse, but they were getting a bit tired, so we replaced all of those a little while ago, and that made quite a difference too. We replaced the gas boiler with an aerated one, and appliances as well, and then we got rid of our coal fire at one point and put in a wood burner. So we did a lot of the things that you would try and do to cut down on your carbon footprint and cut your energy bills. And it made some impact, but not as much as we might have hoped. So we then went on and said, what other things can you do once you've done those kind of basic things? And we put some of the very earliest solar thermal panels, that is our roof there. Those lower ones were a kind of hot water panel called Solar Twin, which, I can't remember how long that is, it's about 15 years maybe. We put those up, and then later we got some PV panels put up. We're in a room for 4, and we have a very annoying house because it doesn't have a south-facing roof. It has east, west, and north. And that was the best we could do there. We got a little bit. So we'd done as much as we kind of thought we reasonably could do. And still, the house is hard to keep warm and comfortable. I suppose the next things we might have done if we'd thought we might stay here for another 20 years might have been to do things like underfloor insulation or internal or external wall insulation. It would be on the inside of the stone wall, I guess. But that's quite disruptive. And we also, as I said earlier, weren't thinking that 10, 20 years' time when we're tottering around with our Zimmers, this isn't the house we want to live in anyway. So we thought maybe we should try and go somewhere else. Now, that brings us to Passive House, because in 1988, this chap, Wolfgang Feist, in Germany, was doing some research projects because he had been reading and discovered, I think, what we kind of discovered as well, that all the things that we're told to do, putting insulation, double glazing, all these things, they help, but they don't help as much as he thought they should as a scientist. And he wanted to investigate why that was. Why was it that all the new houses that were being built in his day with more insulation, but still they were proving hard to heat and keep warm? So he asked that question and did some research. And he looked at ideas from Scandinavia, some ideas from China, some ideas from the USA. And what he came to the conclusion, he was a physicist, a scientist, and he came to the conclusion that the things that people were trying to do to make their houses more sustainable were the right things, but they just weren't done thoroughly enough, in effect. And he came up with the concept of the passive house. And that picture at the bottom left there is the 1990 passive house. It was a block of 4 houses, in fact, in Darmstadt in Germany, that were his experiment, really, that he put into these, all the ideas that he'd come up with, and then measured the effects. And that was the concept of the passive house came to be. Not limited to house. There are passive schools, passive warehouses, passive all sorts of buildings. It could be any kind of building at all. So basically his idea was these things at the bottom of the screen there, that we want what he calls continuous insulation. I'll go into each of these in a little while. That is, well, we've talked about insulation. You need to reduce heat loss by air tightness, that is stopping the drafts, and by controlling the movement of air, ventilation. And also try and maximize the free energy that's on offer from having the building a sensible shape, from trying to get as much solar energy into your house as possible, and trying to recover any heat that's going out of the house. And you'll see there in the middle of that paragraph at the top, I don't expect you to read it all, but it says the remaining heat can be provided by the supply air if the maximum heating load is less than 10 watts per square meter of living space. Now, you might say, well, what on earth does that mean? Well, a typical small house would be between 100 and 200 square meters of living space. So maybe 100 square meters would be quite typical of maybe a 2-bedroomed house. So 10 times 100 is 1,000 watts. In other words, he's saying that a typical kind of 2-bedroom house should be able to be heated to a comfortable temperature throughout the year with the equivalent of a 1 kilowatt heater. That's about the energy that comes from a 1-bar fire or a kettle. So that's the theory of the passive house. So this diagram kind of shows it maybe a bit more clearly. The idea of the continuous insulation. I don't know, do you see my mouse move if I do that? It's the thing is, in most houses that have insulation, they will have insulation in the loft. They might have insulation in the walls. They might even have insulation under the floor. But there'll be gaps between the insulation at these corners. And he realized that that was a really key thing. And what you really need to do is like the tea cozy effect and have the insulation be absolutely continuous all around, so there's no gaps. And the tiny little gaps there, you find if you leave a wee gap there, all the heat just gets out there that would otherwise have gone out the top a little bit more slowly. You need really good windows. Triple glazed is the norm for a passive house. You have to make sure there's no leaks of air. air tightness, they talk about using special sealing tape. Joints that we think you maybe in your house have got, if you look down at your skirting board, there's probably a little tiny wee gap between the skirting board and the wall, or the skirting board and the floor, which might only be 0.5 millimeter. But that little gap, he discovered, that can make a difference. So in a passive house, they use special tape on all joints to make sure there's absolutely no air leakage in or out. Of course, that means that you would all suffocate inside unless you have a controlled way of ventilation, and we'll come to that in a moment or two. And this idea of thermal bridges are kind of weak points, not so much in insulation, but things like where a floor beam joins to the upright of the wall. There might be insulation down to there, but the heat can leak out through here. Or if you've got double-skinned brick walls with metal ties linking the inside and outside, the heat can escape out along those metal ties. So there's a lot of detail. So it's all the things that we know are good sense, but doing them in a lot more detail and care. If you've sealed off everything and you don't want anybody to suffocate in the house, you've got to get fresh air in and out. And the idea is to have what's called a mechanical ventilation with heat recovery. So the idea is this: you've got a system here, and there are places in the house that generate warm air. Kitchen, for example, bathrooms tend to generate warm air from the activities that are going on there. So the pump extracts the warm air from these places down into the pump here and sends it out. At the same time, it sucks air in a different pipe, fresh air in, and distributes that to other rooms, like living rooms and so on. But the key thing is, in there, that warm air, the warm stale air going out, passes through a heat exchanger and gives its heat to the cool, fresh air coming in. And that way, instead of all that heat from these places leaking out, something like 90% of it is kept in the house. So that's a very efficient way of gaining warmth from places where you would lose it in a normal house. So in a normal house, in the kitchen, you'd probably put the fan on in the window to take the warm air out if it was getting steamy and you're losing all that heat. But this way, you get rid of the stale air, but you keep its warmth. So that's the idea of an MVHR system, which is crucial in a passive house. Now, somebody can explain this better than me, or so they claim, and hopefully this will work. It's Passive House in 90 seconds. So let me play this.
Passive House explained in 90 seconds. Does your house have a heater in the basement or maybe a fireplace? Probably also a central air conditioner or maybe a window unit. Did you ever wonder if it was necessary? In 1991, a physicist in Austria, Dr. Feist, built the first passive house. Here's what he did. 1. Proper insulation. It's just like wearing the right winter jacket. It also doesn't need a heater. 2. No air leakages. There should be no holes, small or large, to let hot air out of the house. 3. No thermal bridges. A thermal bridge is like a road for heating energy in which warmth can travel right through your walls. As a matter of fact, most of our houses have thermal highways in our walls where heat can easily travel to the outside. Plus, the house needs proper windows most of the time with triple pane glass. It needs to be oriented properly so the sun can heat it in the winter and shade is provided in the summer. And it uses an HRV, a device that provides the inside with fresh air without letting the heat out. Add all these things up, and it turns out your house doesn't need a heater or air conditioner. So where does the heat come from? A passive house needs 90% less energy, and that can easily be supplied by your body heat, the sun, your appliances, light bulbs, and even your TV. This saves you a lot of money on your heating bill and helps preserve the environment. Did we make it in 90 seconds? You bet we did. Passive house.
So I don't know if you got that. If you didn't get it, just Google Passive House in 90 seconds and you'll get it. Interesting, the thing there about the heat coming from human bodies. Rachel, you're in Lochaber, and the high school down at Ardnamurchan, don't they call that the Weetabix School? because it was insulated to virtually passive house standards. And they say if the kids have had their breakfast in the morning, each one giving off 100 watts, then that's enough heat to keep the building warm, and it doesn't need to have a heating system. So I don't know if
I never knew that. Thank you.
Yeah, they call it. So I've heard that anyway. So if you do all those things, then you get all these benefits. This is a typical amount of energy use of a kind of standard house that's been built, let's say, in the last 20, 30 years. Your standard houses that you'll see on estates, typically the amount of energy that it will use per square metre. Most of that for heating, a little bit for ventilation and electricity. Low energy houses, maybe half that, but if you get to passive house standard, they reckon you can bring the energy use down by about 90%. So lower bills, lower carbon footprint, comfortable temperature all year round, better air quality because you've got that controlled flow of fresh air, healthy because you're taking out the stale air, and you can have filters there that should keep coronaviruses outside when it's bringing the air in, apparently. Quiet, triple glazing keeps the sound down, and affordable. They reckon now that a passive house can be built for maybe just 5% more than a standard house of the same design would be, or maybe 5 to 10%, but certainly no more than that. There are certain criteria, specific criteria, and these are some of them for the passive house. This one's particularly interesting for those that are interested in kind of technical stuff. To be classified as a passive house, the space heating demand, the amount of energy need for heating the house has to be less than 15 kilowatt hours, that's 15 units of electricity per square metre per year. Now, what does that mean? Well, it means that for a typical house of 100 square metres, that would need 1,500 units of electricity. Can you see that bit of my screen? It's hidden in my case. No, I can see it. 1,500 units of energy per year. So that's about £240 worth of electricity if you think of electricity at 14 pence a unit. So it just gives a kind of idea of scale there. There's a special thing that's used in passive house development called PHPP, which is the passive house planning package. And it's a giant, massive spreadsheet, basically, that you put in all the sizes of the windows and walls and all the rest of it, and the technical values for the amount of heat loss. And it calculates how much energy you will need in that particular house. How are we doing for time? Yeah, okay. So there are, I won't say a lot about this slide, but that was the passive house classic, which had to have less than 60 kilowatt hours per square metre per year. There are new criteria being set, higher standards for Passive House Plus, which has to have some renewable energy generation as well, and a lower need for energy. Notice that a passive house doesn't need to have renewable energy, because they talk about what they call the fabric first approach to building. You make the house so well insulated and tight that actually you hardly need any energy at all. So it doesn't matter where your energy comes from in a sense. But they're now moving on to the idea of Passive House Plus and Passive House Premium, which can be awarded if you've got certain amounts of renewable energy generation, which reduces your overall demand from the grid. Now, Passive House doesn't just apply to new houses. Existing houses can be improved to Passive House standard. And that standard is called the EnerFit standard. It's the same principles as Passive House, but the criteria are slightly less stringent because there's some things it's just really difficult to do in an old house. So if we were taking our current house and tried to get it to Passive House standard. We probably couldn't get it quite to Passive House standard, but we might have been able to get it up to the Enerfit standard. And the next slide takes us to a little video, which is a case study of one of these. So let me see if this will work. Give me a thumbs up if it's running okay, and if not, I'll
We used to think
it.
in the summer it was a lovely place to live, and then in the winter we used to start to hate it because it was so cold and drafty and miserable.
The need to improve the energy efficiency and comfort of Britain's existing housing stock is getting ever more urgent to combat fuel poverty and tackle the threat of climate breakdown. Improving the efficiency of our existing housing stock is a lot more difficult than new build. However, the good news is that we can do it. Using the Passive House standard methodology, we can bring our housing stock up to 21st century standards. The Passive House planning package modelling software is a great design tool to help improve the performance of existing buildings. Many of the Passive House principles can be applied in a retrofit situation. Super insulation, continuity of insulation or minimising thermal bridging, air tightness, ventilation. However, there are limitations when working with existing buildings. Form factor, or the basic shape of the building, solar gains and orientation.
Having built several new passive houses, we've used the methodology and the knowledge that we've built up to retrofit some of these hard to treat Yorkshire stone houses. Let's go and have a look. You might have heard the phrase fabric first in building circles. Simply put, this is to getting the building not to need the energy in the first place. In fact, the cheapest energy we can use is the energy we don't use. We're going to be looking at 4 key principles of energy efficient refurbishment using examples from our retrofit projects. Obviously, insulation is a big part of these renovation works, and on the walls, we've had to use internal wall strategy. As we're in the Peak District Park here, the planning authorities would never have let us put it outside. So we have to be very careful with which materials we use. In this case, it's diathanite, which is a compound of lime, cork and diatomaceous earth. We sprayed it on in 25mm layers to build up to a total of 100mm, and we've achieved the U values that we were aiming for. Here at the Cumberworth job, we have the solid or rubble-filled stone barn wall. So we've used a vapor and capillary open mineral, which is made out of perlite and expanded volcanic rock, and it comes in a board section, which you would then stick to the wall with adhesive and lime plasters over the top. With internal wall insulation, we have to be very careful. So we have 3 types of moisture we have to consider. It's rising damp in older buildings without damp-proof courses, rain-driven damp through the walls because the sandstone in this area particularly is quite porous, and then what we call interstitial condensation, which is the condensing of the internal moist air behind the insulation. Both our products here, diathanite and Tec-10, deal with this quite well. They're capillary and vapor open and actually breathe, if you like, as the original walls would have done. Triple glazed windows and doors are also another key element in our insulation strategy. Triple glazing also cuts out cold spots and drafts and adds the comfort of these buildings. A key element in our strategy is air tightness. We like to be able to draw a line completely around the building continuously using different strategies for the roof, floor and walls. In our case here, we've got the diathanite, which is not only an insulator and plaster, but it's airtight as well. In the ceilings, we've got the intelligent Intello membrane with Tescon tapes, which we tape to the wall behind this diathanite. The diathanite goes down right through the intermediate floor and then is taped to the concrete screed in the floor. For the airtightness strategy here at Cumberworth, we have taken the insulation, as we have on all of our jobs, through the intermediate floor. Now, the way we've done that is by taking the parallel joist, floor joist against the wall and moved it in so that we can take this insulation strategy right the way through. So we actually sand and cement or parge that bit of the wall to join the plaster up for each floor. And we also used a room sealed wood burning stove, which has its own designated supply pipe. So we don't have to have a separate vent.
Oops. Right, I'm gonna stop it there because of the time, but if any of you want to see that through, it's worth looking at. Obviously, it's an advert for a particular company, but it illustrates really nicely the way that the Passive House concepts, those 4 or 5 key things, the insulation, the air tightness, ventilation, and the thermal bridging, stopping these things, can be applied in principle to old houses, to existing houses as well. The link, I think I've got the link there in the chat, so if anybody wants to see that whole thing through, it's only 10 minutes, but I'm watching time going on and to leave time for questions, but it gives you an idea of the realities of doing that in a difficult house. One of the things that he talked about was the idea that the shape of a house is important. If you want to be really energy efficient, you want to try and make a house that's ideally a cube is the best shape, because you've got the most volume for the least surface area. And the volume is where you want it to be warm inside, and the surface area is where you lose any heat. So some of the early passive houses look very like kind of just boring blocks, square houses. But these that you're looking at there are all passive house designs. And nowadays, the insulation and the technology has improved so much that passive houses can be made in almost any shape you want, and with any materials. So some passive houses are built from brick, some from concrete, some from timber frame. Any material at all is possible, any insulation material, any building material, all shapes and sizes. So yeah, I think that's me covered the main things. That one at the bottom right there, which I'll show you a little bit more about. This is the house that we're hoping that the planners will allow us to build something kind of like this in Selkirk. It's not an ideal shape. It's kind of forced on us because of the shape of the old church that we're building above. And it also doesn't have lots of windows facing south, unfortunately, which is what you want in a passive house, just because the views from here are best to the northwest. But even with those disadvantages, our architect's been playing with the passive house planning package and reckons we can achieve passive house certification. We're hoping to get word from the planning department this week that we would get the go ahead to start, but we're still waiting. So a little bit frustrating. The last slide, I've just listed some of the places where you will find the kind of information I've been showing you. There's loads of information out there. The Passive House Trust, the International Passive House Association, the Passive House Institute are all 3 organisations that kind of promote passive house methodology and have a lot of useful resources and forums and so on. And the Green Building Store is, that video was from, they supply a lot of the kind of material. Paul, I think it's actually Powell, because I think he started in Germany, is a company that does heat ventilation systems here in Scotland. And we've got a lot of information from going to the National Self-Build and Renovation Centre free workshops. And there is a free workshop coming up on the 21st and 22nd of May. It's absolutely free. It runs like from 10 o'clock to 5 o'clock, and there'll be there'll be several half-hour or 1 hour seminars all day. If anybody's interested in going into more depth, I would say sign up for those free things. It's delivered in person at the centre down in Swindon, but it's also, you can view it by Zoom. And so I would strongly recommend that. If you just Google NSBRC, you'll get a link to that. Right, I'll stop there and hand back.